Hi, welcome back to the Cuzzy Sound channel, and today we're going to have a look at how I made this! Yep, it's the glove sequencer. This is the glove in a little bit more close up. I'll just kind of talk you through what the basic components are, and then I'll show you circuit diagrams, a suggested stripboard layout. Not quite exactly what I've got here, but something similar. So basically what we have, obviously 4 fingers and 1 thumb. It's a 4-step sequencer. The thumb being the common rail, so that's where the CV out is connected to, and then each of the fingers is connected in the same way that you would with something like if you were building a baby 8. The only difference is there isn't a clock on this, obviously. The clock is how you move your fingers. But for each finger we have a potential divider. So we have the power coming in, and go through a limiting resistor, it's just so that we don't put a dead short on the battery. And then there's a potential divider, a voltage divider, and the CV out. So you've got power at the top through the resistor, the bottom end is connected to ground, and then the center tap is where you're going to take off your control voltage. So that provides us with the control voltage, so to kind of change the pitch of your oscillator or whatever else. I'll show you what patch we've got going and demonstrate a little bit of how it works in a while. What I've also added, there's a gate output as well. Now the way that I achieve the gate output is I have a transistor. I'm going to put the circuit diagram up in a minute. There I've got a transistor, and I feed the power supply through the collector and out through the emitter, but I trigger that by putting sharing the CV output that's on the thumb into the base. So I'm basically using the transistor as a switch to switch on a gate signal when I tap things together. So yeah, that's the basic layout. It's all powered from a 9-volt battery. The interesting thing, the fingertips, this copper that's on the fingertips. Now this was kind of scratching my head out how I was going to do this. I got all sorts of ideas: copper pipe, bits of brass, you know, sewing contacts into the glove, and then I discovered this stuff, which is slug and snail barrier tape. What is slug and snail barrier tape? Slug and snail barrier tape is this. It's a sticky back conductive copper tape. So the way I've used it, really, I've just got bare wires from the end of each of these leads trapped in the copper tape, which is wrapped round, and when I make contact I have a switch, and that is essentially all it is. So here's the circuit diagram. So you can see from the circuit diagram what I've been talking about on the layout. So we've got it's fed from a 9-volt battery, and you've got 4 potential dividers, and then on the output you've got a common rail that goes to the thumb, and that gives you that's going to give the CV out to the output jack. That's also shared with the base of the transistor, as I said before, and that provides, from the emitter of the transistor we get a gate output. Now on this circuit I've chosen 47k for the trim pots, and I've chosen 1k as the current limiting resistor on the battery supply. As I said, that's just so I don't end up turning the pots and getting a dead short across the battery. And then 22k on between the emitter and ground on the transistor. You can play around with the values of of those pots and resistors to find out kind of what works best with your system. This was a kind of a starting point for me, and well, as you can hear, it sort of works. Yeah, so that's the circuit diagram. What suggested strip board layout, which isn't exactly what I've got here, because here I'm using a stereo jack out, just to actually keep things nice and trim. But this is a strip board layout that will work. This is kind of how I built my prototype, which there's other videos in this series that show me messing around with the prototype. So yeah, that's kind of pretty much all you need to put it together. So yeah, so there we go. That's the sequencer glove. Oh, these little things, these are just drinking straws that kind of try and stop the wires getting too tangled up. Another thing I found is the back of the circuit board, because all the little pins stick through. On this particular glove, they poke through the glove and dig into the back of your hand. So I've put a little bit of foam on the back just to kind of stop the pins from the various devices that are soldered onto there digging into the back of my hand. So yeah, there we go. So yeah, you can see I've used this stereo jack split into two monos. So I've got gate and CV out. Really simple. You know, if you just want a bit of fun in this, I don't know whether you guys are all in lockdown. We've been in lockdown for a couple of weeks now in the UK. So yeah, just getting creative and having a bit of fun with some electronics and the synth. So talking about the synth, let's have a look at what patch I've got set up and how I'm controlling the synth with the glove sequencer. The patch. Well, the gate out, start with this, the red line cable is the gate out from the glove going into a buffered gate, which allows me to share the gate signal. So the gate signal is going to a Victrol, and it's also going to the trigger on an envelope. The CV signal is going into a 4046 VCO. The output from the 4046 is going into the input on the Victrol. The output on the Victrol is going into a VCF. The output from the VCF is going into the mixer. What we're doing with the envelope signal is the CV out from the envelope is going on to the CV in on the VCF. So here is the glove, and as you heard at the beginning, that is kind of what this patch sounds like. Now, using the glove, what we can do, if I hold or tap, so you can see I can control the pitch simply by tweaking each of the pots that are assigned to the fingertips, and then just by tapping the fingertip and the thumb, well, there you go. The glove sequencer. I've given you all you need to know how to build one of these things, so yeah, get creative. Go on, have a go. Build your own.